Many routers can place limits on the traffic that they send to the destination. It's just like your ingress filtering, where you can specify that attachments over 2 MB cannot come into this network in a mail transmission. Similarly, you can have rate limits placed on the router. Then that ensures that the destination is not overloaded. That is one of the most popular methods for preventing denial of service. And limits can be defined somewhat specifically or flexibly depending upon the organization, its requirements, its needs, but often not enough flexibility to let the good traffic through and stop the bad. So you should not have so much of flexibility. So it basically means that you should have a balance between how you need to be flexible and what you need to allow and what you need to deny, so that the good traffic does not get blocked. We have spoken a bit of traffic. Basically, padding involves when you don't want intruders to know what traffic characteristics that you are sending and receiving. And padding adds extra traffic to hide the real stuff. And fake traffic must look like real traffic. That is more important. So the attacker should not be able to analyze that this is a fake traffic and this is a real traffic. So that means you have to encrypt it all. That means the good traffic and the fake traffic. It must be done very carefully. Otherwise, clever attackers can tell the good stuff from noise. So you are injecting noise into the traffic along with the good traffic, so that it becomes difficult for the attacker to decode what is going on in the network. So what basically happens is traffic padding, it produces ciphertext output continuously, even in the absence of plain text. A continuous random data stream is generated. When the plain text is available, it is encrypted and then transmitted. When the input plain text is not present, then random data is encrypted and transmitted. So it makes it impossible for an attacker to distinguish between the true data flow or real data flow and the padded data. So that it is also difficult for him or her to deduce the amount of traffic that is generated and sent. That's what basically padding does. When we continue with routing control, it uses the ability to control message routing to conceal the traffic in the network. It is used in onion routing to hide who is sending the traffic and to whom. This is used for anonymization purposes. Routing control is also used in network defense to hide the real location of the machine. Example, in SOS DDoS defense system. Here a term onion routing is used. Onion routing is a technique for anonymous communication over a computer network. Messages are repeatedly encrypted and then sent through several network nodes called the onion routers. It is like someone peeling an onion. Each onion router removes a layer of encryption to uncover the routing instructions and sends the message to the next router, where the same process is repeated. So this prevents the intermediary nodes from knowing the origin, the destination, the contents of the message sent. So that is what is called onion routing. Now everybody has heard what is a firewall. Firewalls implement basically a form of security called perimeter defense. Perimeter is the area surrounding your border or surrounding your network. It protects the inside of a network by defending the outside strongly. So it basically filters what is allowed within the network and what should not come into the network is dropped. So it basically controls the entry and exit points. What can go out of the network and what can come into the network. If nothing bad can come in, then I'm safe, right? So that's the general feeling. There are weaknesses in the perimeter defense model also. Now, once an attacker breaches the perimeter, it compromises all security if that's the only layer of security that is available. Now, Windows passwords are a form of perimeter defense. If you get past the password, you can do anything. So take the example that you cannot get inside Windows without giving your administrative password or your user password. But once you get access to the password and log into the system, then you can do anything. So perimeter defense is a part of the solution. It is not the entire solution in itself. This slide indicates that precisely. Now your perimeter is there, there are several nodes inside. The arrows coming in and going out is attacker trying to get into the perimeter. But if he manages to get into the perimeter, attack one node or attack one server, then he is in. He can do anything that he wants. Defense in depth is an old principle in warfare. Now it doesn't rely on a single defensive mechanism or defense at a single point. That is, you should have several layers of security, just like your onion routing. You should have several layers of security where even if you breach one layer, there is some other layer to protect you. And in the center of the onion is the core of where your servers, your network equipment, your data is stored. So you should not rely on a single defensive mechanism, but rather a combination of different mechanisms to protect your information. Defeating one defense does not defeat your entire plan. So like I said, you should have several layers of security, wherein even if one layer is breached, access to the information should still be difficult because there are several other layers before the data can be accessed. So let's say that the attacker has breached the perimeter. What should happen? As you can see, the red dot is the compromised system. The red dot can communicate with the black dot, another system in the network, and traffic can go out. So if there is only one layer of security and if something within that layer is compromised, then your entire network will get compromised. Now there is another slide which says this is even better. So you have put in another filtering mechanism here so that attacker, when he tries to attack or gets past the perimeter, still has to encounter another level of security so that the network is safe. So now here you can see that by adding another layer of security, your computers are not compromised. So are firewalls of any use? Definitely it is of use. They are not the full solution, but they are a part of it or one layer of it. Anyone who cares about security needs to run a decent firewall. They have to do the other stuff also. Now, when you talk about firewalls, there are several popular ones available like Cisco, you have Checkpoint, you have FortiGate. So there are several important or famous vendors available for your firewall. What are the basics of the firewall? What do they really do? They examine each incoming packet and they decide whether to let the packet inside or to drop it. Now that criteria can be simplex, like we explained earlier. If the source address is not in that particular range, drop it. Or it can be complex. It should come from this particular source and it should be directed to that particular port and should have certain other characteristics. So it can be a complex rule also. And basically all the rules or all the filtering that happens in the firewall is logged. So the decision to whether allow the traffic or deny the traffic is logged, so that a forensic can be done on the firewall at a later time if required. It can also send the rejected packets elsewhere, maybe to a different box where the analysis can happen. Or it can send to a security incident and event management tool, SIM tool for log analysis to see what is happening in the network. So basically these are the functions or basic properties of firewall. It is much more complex than that, but what you need to understand is it examines each packet, then it decides whether to allow the packet in or to drop the packet. or it could be send the packet somewhere else. It logs all the traffic coming in if you configure it. The criteria for filtering can be a simple process or a complex process. So that is what basically a firewall will do. The fundamental problem is IP addresses can be spoofed. We have seen what spoofing is. So if your firewall filtering trusts the packet headers, then it offers little protection. If spoofing is allowed, and if your firewall relies on trusting the packet header, then it could be a problem. Now, these situations can be improved by implementing IPsec, but hasn't been yet. Meaning, lot of people do not use IPsec for trusting or to encrypt or to filter the traffic. Firewalls can perform both inbound and outbound filtering. We discussed what is ingress and egress filtering. So firewall can do both inbound filtering and outbound filtering. Again, like I said, it can filter based on the traffic to which port it is directed. So most incoming traffic is destined for a particular machine and port. Meaning it says that it should go to 10.10.1.1 to port 80. So it can filter based on that criteria, then which can be derived from the IP and TCP headers. So it does an analysis of the IP and TCP headers. It allows only packets to select machines at select ports. So again, a firewall, when you configure it, you say that from any system to this particular server, I will allow only port 443. So it can let through packets to select machine at specific ports. If there are 20 servers there and the firewall rule is configured that only to 10.10.1.1 I am going to allow traffic on port 80 and not for the other servers, so it will do exactly that process. And it makes it little impossible, or it makes it impossible to externally exploit for flaws in the little use ports if you configure the firewall right. There are still methods like port marking and other things, but it makes it impossible to exploit the flaws for the ports which are not available to the external attacker. A firewall should basically be invisible or transparent, except when it vetoes access, except when it denies access. Users inside should be able to communicate outside without knowing about the firewall. Means it should be seamless. There should not be a user-unfriendly experience. External users should be able to invoke internal services transparently. Now here, the important thing to remember is when we talk about external users, it is external authorized users who want access into the network. Not external users does not specify all external users. The external users who have a need to do within the network. With that, we conclude the network security aspect. Now, what we have learned in this is the basics of cryptography. What are networks? What are the medias that are used in communication, media used in network? What are the communication channels? What are the protocols, rules of communication? What is the basic of a firewall? There are different kinds of firewall available. You can do a Google search on the different kinds of firewall. There are different generations of firewall available. Then basically what a firewall does. Now what we have not covered in this is what is a port. A port is an invisible window or an invisible channel through which your communication happens. There are 65535 ports in your computer, each one designed for a specific purposes. 1 to 1024 are reserved for the system processes, and the remaining are registered ports, where a user can register or a particular vendor can register that port for a specific service. Now, if you take the examples of different ports, 21 is FTP, 22 is SSH, 23 is Telnet, 25 is SMTP, 80 is your HTTP port, 443 is your HTTPS port. Similarly, you have 110 as a POP port, or even Google uses 465 as your SMTP port, or 587. So different port numbers are there. There are also some Trojan ports. NetBus Sub7 uses ports in the range of 6000 series or 60,000 also. Then you have 3389, which is your RDP services. So there are different kinds of ports for different things. Your database ports, there are Microsoft SQL uses port 1433. Your MySQL uses 3306. Your Oracle uses 1521 to 1526. So there are different services available on different ports. Now again, going into details, of course, you will get what each port is designed for what by Googling. So there is a agency called IANA which has the entire list, or it is a port registering authority where you get the list of all port numbers and transport control ports. It's a transport protocol port registry. So you'll get more information in that. After ports, there are IDS, IPS, which is intrusion detection system, intrusion prevention systems. So IDS basically checks the traffic for malicious activity based on certain criteria on certain database. IPS is prevention system. Then you have anti-spam, email filtering. So there are several aspects when it comes to network security. In the next session, we will go into what is vulnerability assessment, what is penetration testing, how do you basically understand the phases of this VA and PT, what are the generic or popular tools available for conducting the VA PT. We